Hello there. So today we are going to see efficiency measurement on a three-phase motor drive system, right? Let me kind of brief you through the system, right? So what we have here is a three-phase motor, right? That is driven by a GS2 AC drive, right? What it does is it takes three phases from the AC source down there, right? It's coming in right here, and then this guy right here, GS2 motor drive, processes that AC input into a PWM output. It's a high frequency PWM output that goes into this motor right here, right? And then motor is then driven through the shaft into the dyno system, right? And as you can see, we have our power supplies for the dyno, for the GS2 and so on, right? So that's kind of our system, right? We are going to measure efficiency on this system, right? So what we are going to do is we're going to measure efficiency on the input three phase on the first two channels of this power analyzer. This is a PA3000 power analyzer, and we are going to measure the output PWM three phase on the third and the fourth channel. Okay, so that's kind of what our system is, right? And we'll be measuring this in a three phase, three wire configuration on a PA3000 power analyzer, right? All right, so let's go to the software and set up the system where we can set it up for PWM measurement, right, and for efficiency, right, and take it from there. Okay, all right, let's go to the PowerView software and set up the test. Here on the setup page, we are going to select PWM motor drive efficiency, right, here on the left, right, and click on Wizard. Wizard will help us with the wiring setup. As you can see, we are connected in three-phase, three-wire configuration for input and for the output. Okay, with three-phase, three-wire, we just need 2 wattmeter channels on power analyzer to accurately measure three phases. We have our three-phase input on the first 2 channels and three-phase output on the third and the fourth channel. Anyhow, our expected input current is about 3 amps, right? Let's enter that here and click next. We are using internal shunts in this case, as expected current is about 3 amps or so, much lower than the 30 amp shunt rating. So we'll keep the default selection of direct measurements and click next. Okay, let's enter 3 amps for the output as well and click next. This again is a direct measurement as our current is lower than 30 amps, right? Now, if we had a current higher than 30 amps, we would be using one of the high accuracy current transducers. Now, in that case, we can select the current transducers options, from here and select the scaling ratio as required, right? Anyways, for now, we will stick with the direct measurements, right, and click next. Okay. Now, this summary page shows the final connection diagram as we discussed earlier. That's how we have set up our system for now. Okay, let's hit finish. Next, we'll verify the input and the output settings for efficiency measurement. This looks fine here. We have our input and the output groups set up correctly, so that's good, right? Now, before moving on to the measurements, let's quickly look at the setup page, right? You'll notice that the software set the input group as normal, but if you notice this, the output three-phase group is set as PWM mode. Now, what does that mean? Right. This is very important, as the output of the PWM motor drive is high frequency pulse width modulated voltage signal that has an underlying average sinusoidal wave at a frequency equivalent to load current. Okay. Now, it is important to acquire the fundamental load frequency to accurately measure output power. The PWM mode uses a complex algorithm to digitally acquire the fundamental load frequency. I'll say that again. The PWM mode uses a complex algorithm to digitally acquire the fundamental load frequency, which is different than your switching frequency, okay, while preserving all the frequency components of a high frequency PWM signal. This is done for obviously accurate RMS values. Okay. Now, load current can be used as frequency source instead, but they can lead to errors if the current is distorted. Okay. Anyhow, the PWM mode will help us with accurate output power measurements, and we'll select that right here. Right. Everything else looks okay, so we'll go to the measure page, and before we turn on the measurements, let's turn on the motor drive and start the measurements. All right, so let's turn on the rig. Okay, so we are going to turn on this AC source right here on the floor. Voltage check. Now we are going to turn on the airflow. That way, we have some air moving through the system. It doesn't blow up on us. Okay. We turn on the dyno, and there you go. So voltage check, airflow check, AC input check, right? This is going to get loud. So let's get back to the software, run the motion and measure efficiency, all right? So we are back on PowerView software. Let's hit the start button and this will upload all the measurements, and there you go. Okay, all the settings are uploaded to Power Analyzer and the grid is displaying all the requested measurements. Now you can see the sum results on group 1 and group 2 respectively, displaying the equivalent power being measured on input and output of the motor drive. Keep in mind that the connections are in 3-phase 3-wire system, which means the individual voltages on each channel don't have much significance. Okay, those are just phase to phase voltages, or like phase A to phase C, phase B to phase C, right, and not phase to neutral voltages. Now we can check the efficiency on PWM drive right here. It's that simple. To monitor efficiency over load changes, we can trend the efficiency by right clicking on this cell right here, right? So there you go. You can see how the efficiency trends over time. You can change the load if you want to see how it changes with load, right? We'll keep it constant. We can also look at the harmonics. So we can click on the harmonics button right here, which will give you harmonics on all the channels, right? And you can switch between channels if you want, right? There you have it. That's how you test efficiency on a 3-phase motor drive system. Now, if you are interested in measuring torque, speed or thermal inputs simultaneously while you are measuring efficiency, we can use the auxiliary inputs on PA3000, right? So let's stop the measurements momentarily, go and basically go back to the setup page. Okay? So on the setup page here under wiring, there is an option to enable aux inputs. Okay? Aux inputs or auxiliary inputs can be used for measuring any external signal, either from torque sensor, speed sensor, thermal sensor, or any other sensors that has basically voltage, analog or digital outputs. Okay? For example, we can set up the second counter input, as you can see here, as a speed input. Okay? I'm going to enter the unit as RPM and enter the conversion ratio if you have any based on your sensor, right? Similarly, you can set up the torque, temperature or any other sensor inputs you might want to measure. All right, so let's go back to the measure grid, and there you have it. There, that's where it shows up, right? So it will show up as torque and speed, and it will have whatever conversions you had with the units on it. Okay? Obviously, I don't have a calibrated sensor connected to the aux terminals right now, but you can see how simple it is to configure such inputs. Now, we can also calculate mechanical power output by entering the formula here in the formula column, right? So for a motor drive, it will be torque times speed divided by 9.55 or whatever your system is, right? Now, this will give us the mechanical power output, and you can use this output to eventually measure efficiency. So you can input that formula again in the same column. Okay, so there you have it. That's how you measure efficiency on a 3-phase motor drive system, on a PWM motor drive system, right? That was our video, right? If you have any questions, please go to tech.com, and if you have more questions, try and contact us directly, right? I'm Sishank Malap. Thanks for watching.